In this video, we're going to do a trigonometry review. We're going to come back to this picture shortly. For a general angle theta in standard position, we let xy be any point on the terminal side of theta. Let r be the distance from 0, 0 to the point xy. So going back to page 1, this gives you a visual of what I'm talking about here. Notice over here we have angle theta. So notice in this visual, I'm assuming angle theta is acute, which just means it's between 0 and 90 degrees. Okay. Now, r represents the distance from the point 0, 0 to the point xy, right here. Now, y is the distance, it's the perpendicular distance from the point xy to the x-axis right here. And then x is the distance from the origin out to here. Okay, highlighted in blue. Now we're ready to define our 6 trigonometric functions. Number 1, sine theta is equal to y over r. Number 2, cosine theta is equal to x over r. Number 3, tangent of theta is equal to y over x. Number 4, cosecant theta is equal to r over y. Number 5, secant theta is r over x. And number 6, cotangent theta is equal to x over y. And with the 6 definitions that I've presented to you, we can derive a lot of trigonometric identities. And we are going to start now. So let's take a look at something. If we take a look at r over y, this is the same as 1 divided by y over r. Now, I want you to notice something. R over y is the same as cosecant theta. Y over r is the same as sine theta. So cosecant theta is the same as 1 divided by sine of theta. And that's our very first trig identity. Now, r over x is the same as 1 divided by x over r. So it's a nice little algebraic technique. But remember that r over x is the same as secant theta. X over r is the same as cosine theta. So secant theta is the same as 1 divided by cosine theta. And that's our second trig identity. Now, take a look at x over y. This is the same as 1 over y over x. But x over y is the same as cotangent theta. Y over x is the same as tangent theta. So cotangent theta is the same as 1 over tangent theta. And that's trig identity number 3. Now, this one's pretty neat. So we'll come over here for some more room. So we're going to do more trig identities. If I take y over x, now what I'm going to do is I'm going to divide the numerator and denominator by r. So this is the same as y over r divided by x over r. Now, y over r should look familiar. Y over r is the same as sine of theta. X over r is the same as cosine theta. Now, also note, if I look at y over x, that's the same as tangent theta. So if y over x is sine theta over cosine theta, and y over x is equal to tangent theta, we should be able to conclude that tangent theta is the same as sine theta divided by cosine theta. And this is trig identity number 4. Let's do another one. If I take a look at x over y, we're going to do the same thing. Now, x over y, what I'm going to do from here is I'm going to divide the numerator and denominator both by r. So I'm going to get x over r divided by y over r. That we can do that. As long as r is not 0, that's totally legal. Now, we know what x over r is. X over r is the same as cosine theta. And I'm circling that on purpose because I'm trying to get you to focus on x over r. Now, y over r is the same as sine theta. So it looks like x over y is equal to cosine theta divided by sine theta. But if we go back to our definitions, we also know that x over y is the same as cotangent theta. And so if x over y is cosine theta over sine theta, and x over y is cotangent theta, what we can say is that cotangent theta is the same as cosine theta divided by sine theta. And this would be trig identity number 5. Now, let's take a look at something. From the Pythagorean Theorem, we know x squared plus y squared is equal to r squared. So don't forget, we had a right triangle that looks something like this. We just drew the right triangle in the xy plane, but needless to say, it's still a right triangle. This distance was x, this distance was y, and the hypotenuse was r. The hypotenuse was the side opposite the 90-degree angle. Okay? Now, watch this. So, we're going to start here. So, in other words, we're going to start with x squared plus y squared is equal to r squared. And I'm going to divide both sides by r squared. So, what that means is I'm going to divide x squared by r squared, y squared by r squared, and r squared by r squared. Okay? Now, so what we have is x squared over r squared plus y squared over r squared is equal to 1. Now, remember that we have an angle theta here. Okay? Now, x over r is equal to cosine theta. So I'm going to square both sides. So x over r quantity squared is equal to cosine squared theta. But what that tells me is x squared over r squared is equal to cosine squared theta. Okay, so I'm going to take x squared over r squared, and I'm going to substitute it for cosine squared theta. Now, we can do the same thing for sine. Remember that y over r is sine theta. And if we do something similar, would it be fair to say that y squared over r squared is sine squared theta? If we make the same argument? So this is the one for cosine, right here. And this is the one for sine. Okay. So y squared over r squared is sine squared theta. And then we get 1 back. And this is our Pythagorean identity. This is the one we absolutely have to know. Forwards, backwards, and sideways. But what's magical about that one? I'm going to show you. Now, start here. So we'll do cosine squared theta plus sine squared theta is 1. Okay? And what I'm going to do is I'm going to divide everything by cosine squared theta. It's really slick because we know one Pythagorean identity. We can get other Pythagorean identities for free. Okay? Now, cosine squared theta over cosine squared theta is 1. Now, remember, sine theta divided by cosine theta is equal to tangent theta. So sine squared theta over cosine squared theta, that's going to be tangent squared theta. So I'm going to get 1 plus tangent squared theta on the left side. On the right side, now remember, 1 over cosine theta is secant theta. Now, if you can imagine, I'm going to square both sides. So when I square both sides, what will happen is 1 over cosine squared theta becomes secant squared theta. And that's the other Pythagorean identity. Here, let's write this a little better. Now, let's return to our original. Cosine squared theta plus sine squared theta equals 1. Now, only this time, I'm going to divide everything by sine squared theta. And I want you to see what happens. Now, remember that cosine theta over sine theta, that's equal to cotangent theta. So if I square both sides, cosine squared theta over sine squared theta is cotangent squared theta. Sine squared theta over sine squared theta is 1. And then on the other side, 1 over sine squared theta is cosecant squared theta. And that would be our third Pythagorean identity right here. And so once you get one identity, you get other identities, what I would say that are free of charge. And that'll do it for this video. This is a video for a trigonometry review, and I'll call this part 1. Thank you.